Hello viewers, welcome to K Diagnostics, Dio here. Today we have a 2008 Mercedes Sprinter with a 3.0 liter. The customer complaint on this vehicle is the vehicle is losing power tremendously. The customer also stated that this vehicle cannot go over 40 miles an hour. So the first thing we're gonna do is we're gonna go inside the vehicle and confirm the customer's complaint. The customer said that the check engine light is also remaining on while the engine is running. So we're gonna confirm the customer's complaint, and after that we're gonna connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. So now let's go in the vehicle and confirm the customer's complaint. So right there, as you can hear, the engine is running and the check engine light remained on. So right here, check engine light is on. So customer's complaint confirmed. So when I accelerate, I hear a hissing sound coming from under the hood. It sounds like there's a hissing sound coming from either under the hood or under the vehicle. Listen. So I hope the camera is picking that up. So we have confirmed the customer's complaint. So now I'm gonna turn off the engine. I'm gonna turn the key back on. I'm gonna get the scan tool connected to the vehicle. After I get the scan tool connected, I'll bring you guys back up so we can scan the engine computer. I got the scan tool connected to the vehicle. I'm gonna bring it up. So now let's scan this vehicle and see what we got. We have two trouble codes in the engine computer. The first trouble code is 2510 and it says boost pressure regulator control positioner error. And then the second trouble code is 2623 charge as system offset drift at idle. Now, since this vehicle is losing power tremendously, this first trouble code over here will cause that, because this boost pressure regulator control positioner error is usually caused by an actuator on the turbo not working. If the actuator on the turbo is defective, this trouble code is going to be set. And the problem can be the actuator itself or the wiring of the actuator, the wiring between the actuator and the engine computer, or the issue could be stuck vanes in the turbo. Because when the engine computer wants to increase the boost in the intake, it actuates the actuator, which actuates the lever on the turbo to open the vanes to spin the turbo faster to create more boost. And if the actuator is not doing that actuation, the boost is not going to be created and the vehicle is going to lose power. Okay? Now, this other trouble code over here, I've seen a partially clogged air filter cause this trouble code to be set. Okay? Now, replacing the air filter and reinitializing the relearned value in the engine computer can take care of this second trouble code. We're gonna focus on the first trouble code first. After we fix the first trouble code, we're going to erase all the trouble codes and do some reinitializations. And after that, we're gonna test drive the vehicle to see if the vehicle is gonna drive better. But I'm sure this trouble code over here is definitely the cause of our power loss. So I'm going to scroll down. Let's see what else we have in the other control units. So we got 0 codes in these control units. Nothing on the generic side. So we only have 2 trouble codes on this vehicle. So let's go to engine. So we're gonna go into the engine computer. Let's look at the code once again. Okay, our fault codes are there. Now I'm gonna erase these trouble codes. Let's see if these codes are hard faults. So let me clear these codes. Let's see if they're gonna come back. And if they don't come back, we have them saved on the scan tool. So once again, we have erased the trouble codes. Now let's go to codes. Okay, so this one over here is still on, but the actuator one is gone. Let me start the engine. So the engine is running. The check engine light is off because we just erased the trouble codes. Let me turn off the engine. Let me turn the key on. Let's read the codes again. So right there, our 2510 trouble code came back. Boost pressure regulator control positioner. Okay, so we're gonna go after this trouble code. Now, what I wanna do is I wanna back out and go to data. Let's go to boost PSI control. I wanna look at my boost data PID, and we're gonna test drive this vehicle to see how this vehicle drives. Okay, so I'm gonna graph my boost pressure data PID. I'm also gonna graph my boost PSI actuator duty cycle percentage. So we're gonna graph these two data PIDs. We're gonna go for a test drive, and then when we come back for a test drive, I'm gonna tell you what we're gonna do after that. Okay, so let's test drive this vehicle and see how it drives. And this thing has a long crank, so I'm gonna be watching the data as we are driving. Okay, so right now at idle, our actuator duty cycle command is 10%. Okay, right here, 10%, and our boost pressure is 1097 HPA. Okay, which is low. So the max number we hit, the max boost was 1317. All right, so I'm gonna watch the data as we're driving. So let's take this for a spin and see what happens. All right, guys, so I'm test driving this vehicle. This vehicle is losing power tremendously. I'm stepping on the accelerator pedal all the way to the floor, and the vehicle cannot even go over 15 miles an hour. Let me show you my foot that's on the accelerator pedal. So watch that. I'm stepping all the way to the floor, and look at this. You see this over here? So this vehicle is losing power tremendously. So customer's complaint confirmed. So now let's drive back to the shop. Okay, I don't want to drive this any further because this vehicle is not even getting out of its way. It's really losing power. I'm gonna turn around and drive back to the shop. So I'm gonna drive back to the shop, and then when I get back to the shop, I'll bring you guys back up so that we can diagnose this. Actually, right now, I feel like the engine is shaking a little bit. Okay, so let's drive back to the shop. Man, this is crazy. No power at all. See this over here? This vehicle won't even go over 15 miles an hour. This is crazy. All right, I'm gonna get this in the shop and then I'll bring you guys back up. All right, guys, we are back here at the shop. As you can see, the check engine light came back on. So I'm gonna turn off the engine. So let's look at the scan tool. So the max boost we got as we were driving was 1332 HPA. Okay, which is really low. So let's back out of this data group. Let's go to codes. Let's look at the codes again. So our same trouble codes came back. So I'm going to go after this first trouble code first, because if the actuator is not working, this engine is not going to be able to create enough boost to give power to the vehicle. Okay, now we're gonna go under the hood and check the actuator on the turbo. We're gonna check the actuator wiring first. If the wiring of the actuator is good, we're gonna replace the actuator. So now let's go under the hood. We're gonna do a visual inspection in the engine bay and under the vehicle. And after that, we're gonna use a smoke machine to smoke the induction system to see if we have a leak in the induction system. Because a leak in the induction system will cause a Sprinter van to lose power. I mean, any vehicle. So we're good over here. I don't see anything that stands out. So let's go over here. Now it's a little dark back there. I don't know if the camera is gonna pick that up. So it looks like we have an exhaust leak back there. So everything here looks good. So now let's go under the vehicle and do a visual inspection under the vehicle. So we are here under the vehicle. Man, there's a huge exhaust leak over here. It's really dark down here. So check this out. It looks like somebody welded this diesel exhaust catalyst. Okay, so we have an exhaust leak over here. So the hissing sound that I heard when I was in the vehicle, I guess is coming from here. So this exhaust leak has to be fixed. Now, this exhaust leak is not gonna cause the vehicle to lose power, okay? So let's not get sidetracked by this leak over here, but this is something that needs to be taken care of. So it looks like someone worked on this exhaust system. So let's go back here. So this over here is our DPF. We have a Dorman part number here. So this is a Dorman product. As most of you know, Dorman products are not the best. So someone installed a Dorman DPF here. So it looks like we have a gap over here between the pipe that goes to the back and the DPF. It's a little loose. So we can potentially have an exhaust leak over there. Okay, so we have a huge exhaust leak here. All right. So everything else looks good besides this huge exhaust leak that we have over here. So now let's lower the vehicle and let's go back under the hood and continue with our diagnosis. We're gonna use our smoke machine to send smoke down the induction system to see if we have any leaks in the induction system. Now we're gonna undo this clamp over here. I just wanna kind of rule any potential leaks out of the way, because if we have a leak in the induction system, we can still lose power. Okay, so we're gonna use this bladder. You guys have seen me use this. So we're gonna use this bladder and send smoke down the induction system. Alright, so that's good enough. Now I'm gonna turn on my smoke machine. We're gonna wait until smoke starts coming out of this tube. So as you can see, we got smoke coming out of this tube. So we're gonna connect it to this tube over here. Although our actuator on the turbo is not working, But after fixing that, if we have a leak in the induction system, we're still gonna lose power. So we gotta make sure that our induction system is good. So now let's watch. Let's wait a couple minutes. As we're sending smoke down the induction system, we're gonna look around the engine bay and see if smoke is gonna come out of somewhere. Now I see smoke over here. I don't know if you can see that. You see that right there? We have smoke coming out of the silencer. We have a leak over here on this silencer. You see that? So we do have a leak up there. So the black O-ring on the silencer is leaking. So we have a huge leak right there. So we're gonna have to replace that seal. So that's good to know. Okay, so we got a leak right there. That's good. So we know we have a leak over there at the silencer. So that's good to know. Now let's turn off our smoke machine. We're gonna fix that leak. Let's remove our bladder here. Okay, so now I'm gonna get our smoke machine out of the way. After I get the smoke machine out of the way, I am going to show you where the silencer is leaking from, and after that we're gonna test the turbo actuator. So now we're gonna remove the air filter box. We're gonna unclip this power cable, and then we're gonna pry this up. We're gonna disconnect our mass airflow sensor, and then this temperature sensor here. So we're gonna pry the air filter box up. Now we're just gonna pull it out. Here is where we had a smoke leak. So this gasket is leaking, okay? So basically the air that the turbo sends out, the charged air, goes down this tube and then down this tube, and it goes through the charge air cooler and then into the intake. So if we have a leak over here, once we get the turbo to work fine, if we have a leak here, all the charged air compressed by the turbo is going to be leaking from this point, and that's going to cause a power loss also. So we're going to have to remove this seal. There is a seal over here and there's another one back here. So once we remove this silencer, we're going to have to replace both of them. Okay, now next thing we have to test is this guy over here, the turbo actuator. Remember, there was a code about this actuator. So now what I'm going to do is, before we check the wiring, I'm going to use my RTL scan tool. My RTL scan tool has more bidirectional test than my Snap-on scan tool. I'm going to use my RTL tool to actuate the actuator. Okay, let's use that RTL tool to see if we can actuate the actuator. If we can actuate the actuator, then our problem is not going to be at this point. So let me grab my scan tool. Actually, let's try the Snap-on scan tool first before we connect our RTL scan tool. Alright, so I'm going to turn the key on. My Snap-on scan tool is still connected to the vehicle. Now, let's see if this Snap-on scanner is going to do the bidirectional test. Let's see if it's going to activate that actuator. So let's back out. Let's go to functional test. So we're going over here, functional test. Let's go to Actuator test. Boost PSI actuator. Okay, this one is asking us to start the engine. The engine has to be at idle. No. Let's start the test. Now, as I'm starting the test, if we watch the actuator, nothing is happening. Okay? So we got no movement at the actuator. So we either have an actuator that's not working, or maybe a problem in the wiring between the actuator and the engine computer, or the test on the scan tool is not working. Okay, our snap-on scan tool could not be supporting that test. I'm gonna switch scan tools and then I'll bring you guys back up. I got my Autel scan tool connected to the vehicle. We're gonna go into the engine computer. Let's press on 100. I don't see any movement on the actuator. Let me put the light over here so you can see. 40%, 20%, nothing. So as I'm commanding the actuator, we should see the lever over here. This lever of the actuator should be moving up and down. So this lever over here should move. As you can see, it's stuck at the bottom. Okay? So the lever of the actuator is not moving at all. So let's command it to 40%. Right there, nothing is happening. Now, we could have a wiring problem between the actuator and the engine computer. Now what I'm gonna do is I'm going to remove this tube so we can get access to the actuator wiring. And then we're gonna test that wiring. You see how wet it is down here? I'm gonna notify the customer about how wet this area is. So this turbo is leaking. Now, we're gonna continue checking this. Okay, so we have 3 wires over here. The first wire on the left, so this wire over here is gonna be our power supply. Okay, it's a black wire. So the black wire here is gonna be the power supply. The second wire, it's brown. The brown wire is gonna be our ground. And the last one is gonna be our control, the control for the actuator. So I'm going to use a back probing tool. So we're gonna use this to check the first 2 wires. So let me back probe the power supply wire first. So I back probed this wire. So we're gonna use our test light to make sure that we have power and ground going to the actuator. So I'm gonna connect my test light to ground. So we're gonna connect it over here. So test light connected to ground. Now we have power at this cable here. Let me reconnect my test light to ground. If I touch power, my test light is gonna light. So right there, test light lights. So now I'm gonna touch my back probing tool over here. So if we have power on this first wire over here on the left side of the actuator, my test light is gonna light. So I'm gonna touch my back probing tool here. So right there, we have power at the actuator over here. Okay, so there's power at the electrical connector of the actuator. So now I'm gonna move my back probing tool to the second wire, which is the brown wire, the wire over here in the middle. Okay, so now we are back probing the brown wire. Now I'm gonna switch my test light to battery positive. So I'm gonna connect my test light over here. Let me see if I can do this one-handed. Okay, so we got our test light connected to battery positive. If I touch ground, my test light is gonna light. So right there, every time I touch ground, my test light lights. So when I touch this back probing tool. Since we are back probing the brown wire, which is the ground, when I touch it, if there's ground there, we should have a test light that's gonna be lit up. So watch this. So right there, my test light lights. So we have ground on this second wire, on the brown wire. So now we're gonna test our control wire, which is the last one. It's a gray wire. I hope you guys can see what I'm doing here. Now let's test our control wire. Now we're gonna back probe the control wire. Okay, so what happens on the control wire on this actuator is the computer grounds the actuator. Okay, so it sends ground on this control wire to actuate the actuator. So you have power on this first wire, you have ground on the second wire, and the computer actually sends ground on this third wire to actuate the actuator. So now what I'm gonna do is, since the computer sends ground this wire, my test light is already connected to battery positive. Again, if I touch ground, my test light is gonna light. So we're gonna back probe this control wire over here. Okay, as you can see, I have my test light connected to our back probing tool. Okay, that's back probing the control wire. My test light is very dim right now. Now, when I command the actuator on with the scan tool, my test light should get bright. If our circuit is good, okay? If the circuit between the computer over there, between the engine computer and the actuator is good, when I command it on, this test light should get bright, okay? So, watch this. You see that? Test light got bright. Okay. So when I go to 20%, my test light gets bright. When I go to 0%, my test light is bright. Let's go to 100%. So this is the 0 position, kind of. See right there? Test light is dim. Okay. So let's press 20%. So right now my test light is dim. Watch when I press 20%. My test light is gonna get bright. See that? Test light got bright. Let's go to 0%. So what we're doing is we're changing the position of the actuator. If the actuator was good, we would see a movement on the arm of the actuator. Okay, so our test light get bright. Since my test light is getting bright, this tells me that our circuit is good. Okay, so if I back out of this test, you see my test light will become dim. See, I backed out of the test, my test light is now dim. So this tells me that we have control coming to the actuator. So the wiring of the actuator is good. Now I'm gonna get my test light out of the way. In case you don't have a scan tool that has bidirectional controls, I know some of you don't have expensive scan tools. I'm going to show you how you can do the same test with a multimeter. I'm going to show you a quick test you can do without having a fancy scan tool. Let me get the scan tool out of the way. You can do the same test with a multimeter. I'm going to show you that really quickly, and then we're going to remove this actuator. This actuator is bad. Since our wiring is good, we have power, we have ground, we have control getting to the actuator, and the actuator is still not moving. So this arm over here is not moving. That tells me the actuator is bad. This actuator needs to be replaced. Okay, but let me show you how you can test this with a multimeter, and then we're gonna remove that actuator. Okay, so let me get this scan tool out of the way. We're gonna turn our multimeter on, and we're gonna be on the voltage scale. Okay, now you're gonna connect your multimeter to ground. So I already got my multimeter connected to ground. Okay, so the black lead goes to ground, and the red lead is gonna go to my control wire. Since we already checked our power and ground wire, so we're not gonna check that again. But the first thing you do is you check for power and ground at the turbo actuator. So the first wire over here is going to be your power wire, and then the wire in the middle, the brown wire, is going to be your ground wire. We already checked those with the test light, so we know we have power and ground at the actuator, so we're good. So the first test we're going to do is we're going to do the unplug it test. So I'm going to disconnect the electrical connector of the actuator. Okay, so unplug it test. Now with the unplug it test, what you want to do is you want to connect your test lead to a back probing tool, and you need to back probe the control wire, okay, this gray wire, the third wire. Now with the connector disconnected and the key on, we're gonna have 3 volts on this control wire, okay, about 3 or 3.5 volts on this control wire. So let's back probe it and see if we have voltage there. So now I'm back probing the control wire. Let's see what voltage we have. So we have 3.30 volts. Now this control wire is coming from the computer. So since we have 3.30 volts on this control wire, this tells me that my wiring from the engine computer to the actuator is good. And this voltage is coming from the engine computer, okay? Now, on a good actuator, and this is from experience, when your actuator is good, when you have your electrical connector of the actuator unplugged, you should have 3 volts, like I said. As you can see, we have 3 volts there. Now, when you connect it to the actuator, this voltage is gonna jump up, okay? So with the key on, engine off, you plug the actuator in, the voltage is gonna jump up, okay? Now, as you can see right now, the voltage jumped up to 10.40 volts. Now, do you see how this is kind of going back and forth? See, I'm moving the actuator here. Watch that. As I'm actuating this, actually I can feel the actuator vibrate. So I let off, we have 10. See, it's going all over the place. It's going between 10.40 and it goes down to 0 volts. So this is abnormal. If I move the actuator here, if I move this lever, our voltage goes down. Now, on a good actuator, the number you should look for is 7 volts. Basically, when you reconnect the electrical connector of the actuator, you should have 7 volts on the control wire. So your voltage should increase from 3 volts with the electrical connector unplugged to 7 volts with the electrical connector plugged in, okay? Now, the other extra 5 volts, I believe, is the voltage that the actuator leaks back into the control wire. Like right now, our voltage is going all over the place, right? Now, if I disconnect the electrical connector, you'll see that our voltage is gonna go down to 3 volts. Let me unplug this. See that? So I unplugged the connector. We have 3 volts. So 3.30 volts. This is a test you do to check your wiring. So the control wire is good. But when you reconnect it, right there, your voltage should go up to 7 volts with the actuator plugged in. If it goes up, it means your actuator is bad. So as you can see, we have 10.40 volts, which is high. And as you can see, the voltage is jumping up and down on its own. And this voltage should be steady around 7 or 7.5 volts. Okay, so again, this actuator is bad. So I'm just tapping on the actuator. See that? So the gear, the mechanism inside the actuator is bad. Okay, now I'm gonna get these tools out of the way. Now I am going to remove the actuator. Let's get the actuator removed and replaced. Okay, I'm gonna get a new actuator and replace it. I'm also gonna replace this seal over here and then this one over here. Now replacing this seal is really easy and straightforward. We're gonna undo these 2 bolts, and then there's another bolt back here I have to undo. Okay, and then I'm gonna remove this tube and replace those seals, and after that we're gonna remove the actuator. To get the actuator removed, we're gonna have to undo 3 bolts back here that hold the actuator on the turbo. Once we undo those bolts, the actuator is gonna come out. So now let's do that.